This kind of equation can look pretty strange the first time you see it. X raised to the power of x equals e. But don't worry, it's actually much easier to solve than it looks. As you can see, on the right side of the equation, we have the constant e, which is approximately 2.7183. Now, what value of x makes this equation true? Let's try some values. If x is 1, then x to the power of x equals 1. And if x is 2, then x to the power of x equals 4. Clearly, the value of e lies between 1 and 4. So the correct value of x must be somewhere between 1 and 2. Now the question is, how can we actually solve this equation? We can solve this algebraically. That's why we use a numerical method, the Newton-Raphson method. Here is how it works. We start with a function, f of x equals 0. Then we use this formula. X sub n plus 1 equals x sub n minus f of x sub n over f prime of x sub n. To begin, we need an initial case called x sub 0. From x sub 0, we find x sub 1. From x sub 1, we find x sub 2 and so on. Each step gets up closer to the answer until the values finally converge. But before we use this formula, let's make the equation simpler by taking the natural logarithm of both sides. According to the log rule, the exponent multiplies the logarithm. So ln of x to the power of x becomes x times ln of x. And we also know that ln of e equals 1. By moving the 1 to the left side of the equation, we can define our function, f of x. So f of x equals x times ln of x minus 1. Now the next step is to find the derivative of f of x. In other words, we need f prime of x. But we only need to find the derivative of x times ln of x, because the derivative of 1 is 0. Now, to find the derivative of x ln of x, we use the product rule. That means the derivative of the first function, which is x, times the second function ln of x, plus the first function x times the derivative of the second function ln of x. The derivative of x is 1, so 1 times ln of x just becomes ln of x. Now for the second part, by this rule the derivative of ln of x is 1 over x. So x times 1 over x just becomes 1. The first part gave us ln of x, the second part gave us 1. Putting them together, we get ln of x plus 1, which means f prime of x equals ln of x plus 1. Now we have both f of x and f prime of x. So let's plug them into our formula. Now we need to choose an initial case for x, what we call x sub 0. Let's pick 1.5 as our starting value. By plugging 1.5 into the formula, we get x sub 1, which is approximately 1.7788. Then using the same process, we find x sub 2, which is about 1.7637. We keep going and calculate x sub 3 and x sub 4. As you can see, they all converge to about 1.7638. So the solution for x is approximately 1.7638. Now let's solve this equation using the same method in Python code. From our manual calculation, we got about 1.7638. From the Python code, we got about 1.7632. The difference is very small because the code used more decimals, while we ran it in the manual steps, so the solution is approximately correct. And finally, here is the graph of the function. As you can see, the curve and the line intersect at the point 1.763. That's exactly the solution we found. So we're done. Thanks for watching and don't forget to like and subscribe for more tutorials.